So, hello everybody, and welcome to this 70, uh, WarsawJS Meetup. Um, I will start with something that happened to me 3 months ago, something like 2 weeks before the quarantine, the coronavirus quarantine in Israel. So a customer contacted me, and they asked me if I can come and help them with a very big problem that they have. What the problem? The problem was their app that was used by fire department. It's a fire department application, was crashing from time to time, and they thought that it's related to some memory leak. So I heard memory leak, and I love challenges. I jumped on the wagon and started to and came to them and started my investigation. And 2 hours after I started my investigation, I found that what happened in their application was that they had some observable that was not released by the page. And when you are moving from one page to another page, the observable stays in memory. Unfortunately, the observable was a data source of 40 megabytes. So if you have 40 megabytes in memory, and whenever you move from one page to another, that 40 megabytes stays stuck in memory, and then you come back and you use another observable with 40 megabytes, then your memory is going to be very big. It's like cloning, and what can happen when we are cloning something? Yeah. So what we did was we used a method that is called take until with the observable, and we released the memory, and poof, everything works as expected. No more memory leaks. And as you understand, this talk is going to explain a little bit about memory leaks and how we can detect memory leaks both in the front end, and also a little bit about how we detect memory leaks in Node.js. So stay with me. A little bit about myself. If you don't know me, I'm Gil Fink. I'm the CEO of Sparksys. This is my own company. We have only one employee, me, myself, and I. I also do the cleaning in my house, which is my office. I'm both a Google Web Technologies GDE and Microsoft Technology Development MVP. I wrote a book called Pro Single Page Application Development back in 2014 that explained how to create SPAs. Back then, I used a library that is less used today, called Backbone, but still the rules that I talk about in the book still applies for today. So I'm talking about routing, testing, and a lot of good things about how to create your single page applications. I also run two conferences in Israel, Angular App and React Next. Both of the conferences currently aren't scheduled. We delayed the conference to around December. So if you want to come to Israel on December and there won't be any coronavirus, then feel free to come and join us in the conferences. So what I'm going to do right now is the following. First, we'll talk a little bit about application memory. What is application memory? How we use the application memory. Then we'll talk about memory leaks in JavaScript, both in the front end and in the back end. So a memory lifetime. When we're going to use a memory in our application, there are 3 steps that we are going to do. First of all, allocation. We allocate the memory that we are going to use. Then we use the memory. The operation system allocated the memory, we read from the memory, and we write to the memory. And then we release the memory. If we're not going to use the memory should be released, and we return to the pool of free memory. And when we are talking about memory, we can express a memory as a connected graph. What I mean by connected graph, you have a root, and from that root we start to use memories and references from one place or one object to another object and another object and a third object, and etc., etc. So if we're looking at this diagram in this slide, number 1 is going to be our root. But what about number 0, that node that we isn't referenced? So this is the place that garbage collectors comes into place. So a garbage collector is a software that is responsible to release memory or to collect memory that isn't used. So what the garbage collector is going to do is look out for unreachable objects, and if it finds unreachable objects, it will remove those objects from memory. There are more than 2 known algorithms for garbage collection, but the most known algorithms are reference counting garbage collection and mark and sweep. So what is reference counting garbage collection? An object is said to be garbage or collectible if there are 0 references pointing to it. If we're looking at A here in the slide, then once we are not using it, it is not referenced, the counter of references is becoming 0. And because of that, B is also not going to be referenced, and we will remove from memory A and B. So this is reference counting. If we're talking about mark and sweep, which is the main algorithm in V8, the engine that runs JavaScript in Chrome, then mark and sweep is going to be to do the following. It will detect a root, which is going to be a global in Node.js or window in the front end. And from that root, it will find all the references, all the allocated objects that are being referenced. And if something isn't referenced, isn't marked during that phase of marking, then it's going to sweep it out of the memory. So this is in practical the 2 main algorithms that are used in garbage collection, and V8 is using mark and sweep. So what is a memory leak? Memory that you are not returning to the pool of free memory is considered a memory leak. And you know, that can't happen in JavaScript. It will happen in JavaScript. It will happen in your application. You are probably having some sort of a memory leak even right now, okay? But it's containable. It's not like the example that I gave from my customer. So common JavaScript memory leak pitfalls, or things that can cause memory leak in your application. First of all, accidental global variables. If you're creating variables in the window, they are considered global variables. But in the past, you could create variables even if you haven't used var, let, and const. So this can be solved very easily if you are going to use the string use strict in your application once, and you won't fall in this pitfall. So this pitfall is something that shouldn't happen in your applications. Another thing that can happen, and it happens a lot, forgotten timers and callbacks. What I mean by that, you're creating a timer, for example, an interval, set interval, you're not releasing that interval, and then the callbacks will keep on running and running and running and running, even though you might not need them. So you should beware of this pitfall. If you should release timers and you should release callbacks. Closures. We love closures in JavaScript, but closures are one of the places that might cause a memory leak. And why is that? Because if you have a closure, then the function that created the closure stopped running, but the variable inside of the function is still alive in memory. And if it is still referenced in memory, then it can create a memory leak in the end, because if you forgot that closure and you never released it, then it's in memory, it's stuck in memory. Last but not least, out of DOM references. You're creating a reference in your code, for example, to some DOM element, and then you detach that DOM element from the DOM in the front end, that there is still a reference in your application to that DOM element. So it's not going to be released, and then it might create a leak. So once you understand or you think that you might have a memory leak, what is the process of profiling a memory leak? First of all, the first thing that you're going to do is establish a baseline. What I mean by that, you can create a new branch of your application on the side to investigate the memory leak and to try to figure out how to solve it if you have a memory leak. You should use incognito mode in order that there won't be any extensions that running in the background and will affect your measurement. After you establish a baseline, you will collect the data. How do you collect the data? We'll see that later on in a demo, but you're going to collect the data in your application. Then you will analyze the results. You will try to figure out if there is a memory leak. And a memory leak is something that you will find over time. What I mean by over time, you will, you need some time that the application will run in order to detect that there is something that causes increase of memory in your application. So you will analyze the results and you will try to understand what if there is a memory leak. If you find a memory leak, you will try to tune up the application. How do you do that? You just, try to figure out, for example, take until, what I said that helped my customer. After you tune up the application, you will test and measure again. You will try to figure out if the memory leak still exists and if your fix solved it. If not, you will collect data again, analyze the result, tune up, test and measure, and etc., the cycle of profiling. So I understand how the process of investigation works. How can we detect memory leaks in the front end? So you will probably use the browser DevTools. Chrome comes with a very big options or nice options to find memory leaks. Another place that people sometimes forget is you have the window.performance object. It exists in the front end, and you can use it to take snapshots of the application performance. So this is something that I won't show you, but let's see a demo how you can detect a memory leak in your front end. So I have a small page here that will create a memory leak. Let's run that page. Okay, we have a button here that will run the memory leak, and we have a different button that will stop the leakage. So first of all, you establish a baseline. You probably create a new branch of your application. You will use incognito mode, and then you will open the DevTools. So I'm using Chrome here, and first I want to show you something that people don't know, the performance monitor. The performance monitor helps you to look at the amount of DOM nodes, the JS heap right now of this web page and everything else. And you can see that it's flat. And I can start looking, and what you're going to see here is we have the graph here changing a little bit. So let's stop the leak. And you can see here in the purple that the memory usage, the JS heap size, is going up and up and up. And the amount of DOM nodes also got up a lot. So this is one place that you can monitor or see changes in the performance of your application, and you might detect some memory usage or high memory usage here. So this is a tip here, performance monitor. The second place that you can use is the performance tab. What I'm going to do here is I'm going to start recording, and I'm running the leak again, and I'm stopping the leak, and I will finish here. So things to notice in the developer tools. This blue line here is the memory usage, okay, the JS heap. And you can see here that it's getting higher and higher and higher over time. Also, I can open this graph here, and it's giving me also the same thing here. JS heap, you see that we have a heap here that getting higher and higher, and also the amount of the green line here is also getting higher and higher and higher. Okay, so this thing can indicate that we have some memory leak. Last but not least, the memory tab. The memory tab enables you to take snapshots during time. So I can take the first snapshot. It's going to be my baseline. And then I will run the leak again. And after a few seconds, I will stop the leak. And you can see here that currently we have 11.5 megabytes consumed by the application. I will take another snapshot. And it takes a little bit time because, okay, we have 14.3 megabytes right now. And what we can do here is use the comparison option to compare the snapshots. And we can see here that a few things changed. We have 2,700 more HTML div elements here and text here. And we can see that the array size was a little bit, bigger during time. So why is that? So let's take a look at the code that created the memory leak, and let's understand what is happening. So in the application here, once I'm pressing the leak button, what is going to happen is I'm setting an interval and I'm pushing to some array, a new array every 500 milliseconds. And I'm also creating nodes. What is creating nodes doing? It adds more 100 more div elements to my application. Okay, so both of those things creates my memory leak. And by using this example, this small example, you can see how we can use the developer tools in order to detect memory leaks, either using the memory tab or the performance tab or the performance monitor. So let's continue. We understand now how we can detect memory leaks in the front end. How we can detect memory leaks in Node.js. So Node can be run in inspect mode. What is inspect mode? You run Node and then -- inspect, and this will enables you to open the developer tools and to use the same method that we used in the front end, but in the back end. Also, there are another tools that we can use in Node. We can wire Node memwatch or head dump, which are basically two out of a lot of options that you can use today in order to monitor your application from your code. So you can use either code with the memwatch and head dump, which dumps some dumps outside your application, and then you can test and measure the dumps and try to understand the memory usage and if there is a memory leak. And of course, we can do it using the inspect mode of Node. So let's take a look at how we can inspect things in Node. So I have another application here that simulates some, some small memory leak. So I can run Node inspect on index.js, and later on, let's open the browser here. So I can open the browser devices tab here, and I will have to wait a little bit until I will be able to monitor. Okay, you can see here that I can now inspect my application. Okay, I will take a snapshot right now, and the memory usage is small. Now I can do the following. I can blast the application with a lot of HTTP requests using a tool like AutoConnon, or if you like, there is another tool called Siege, and there are other options as well. So I'm starting to blast for 30 seconds my server with a lot of requests. And now I can go here and I will take another snapshot, and you can see that the memory usage got higher and higher. And if I'll go back, you can see that the blasting of the server is continuing. And now I can take another snapshot, and boom, we have 9.5 megabytes. So what's going on here? Again, I will take a comparison, and you can see here that I have a lot of new date objects in memory and the numbers, and I can show you. Let's try to find it. Nope. I can see it. Okay, so one of the problems, or the main problem in the application, is some array, and I didn't find that array here. Let's find it again. Sweep it much. Didn't find it. Okay, so again, the problem was an array in the application. What's going on? So this is the entire server, and it's hilarious that 12 lines of code can create a memory leak. So the problem is this array, uplog ARR. This array, in each and every HTTP request, pushes the URL and the request date to that logger. And that's not a good idea to have in-memory logging inside the Node.js application. Okay, you will want to use some file or some other measurement, another way to hold the logging. So this is an example of how I in a simple way can cause a memory leak inside Node.js without even understanding that this small thing here, just pushing some data to array, can cause very, very big problems in the end. So now we know a little bit about how we can detect memory leaks in the front end, a little bit about how we can detect memory leaks in the back end. So JavaScript memory can, and it will leak eventually. So what I'm suggesting is, please monitor your production. Even in your front end, you should monitor your production. Sometimes application will crash, like fire department, critical application that crashes because of memory leak. Okay, that's a real example that happened to me 3 months ago. Be prepared to solve the leak problems that you find. And I know finding memory leak is not like a magical thing that will happen in seconds. It's something that will take a lot of time, sometimes even days. But once you will find the leak problem and you will solve those problems, you will feel very, very good about yourself, because you will understand that you helped to find something that is very elusive on one hand and fix it. So with that, thank you very much for the attention. And if you want to follow me, I'm at Gil Fink in Twitter. And that's everything that I had to say. So we will start with the questions and answers.
Okay. Can you hear me, Gil? Okay, I'm on. Congratulations. Great applause for Gil. Unfortunately, it's not the same feeling as in the conference room, but still, you can imagine a lot of people who clap and are happy with your talk. We have some questions. One of them is, Gil, what problems can occur, as I understand, according to in relationship to memory leaks?
Okay,
you mentioned production crash, but okay.
Yeah. So things that sometimes the application won't crash, but you will see that there is memory usage. You can open not only the tools that I used. I don't know if I'm still screening my screen, but you can go to the browser mode tools, for example, and the task manager. Okay, and then in the task manager, you can see the memory footprint of each and every tab. And if the memory footprint of your tab is very big, for example, StreamYard right now is consuming a lot of memory. Okay, and that's okay because I'm streaming video right now. But if you see those things, it might indicate that you have some memory leak. And other things that can happen is your application will start being slower and slower and sluggish. You will feel that. You will feel that something isn't wrong. Is wrong in the application. Animations won't run very smooth or things like that. That indicates that there are performance problems in the application or a memory leak. Okay, two things that can happen, and both of them needs to be profiled and later on to find. Either it's something that you created that causes a performance problem or a memory leak. But the worst thing that can happen in memory leaks are the application crashing. Okay, meaning that the tab in the browser isn't responsive, and you will see that computer that I don't know if you ever saw a tab crashing in your lifetime, but it's like a figure of a computer crying, and Chrome will say to you, do you want to reload the page, or the page isn't responsive anymore, things like that. So you don't want to get there. That's the thing that happened in the fire department example. Okay, after 2 hours of using the application, or 3 hours, the tab was crashing, and that's not a good idea for a critical application. Okay,
Gil, one
so
more question.
yeah.
One more question from Jakub Sołkowski. Can you explain the problem with circular references in memory leaks?
Okay, so circular references can cause a memory leak mainly in the reference counting algorithm. Okay, if we're using mark and sweep, it won't be able. It will be able, or V8 will be able to detect that there is a circular reference, and will try to clear the memory. But if you're creating one reference to an object and then a backing reference to that object from the same object that you referenced, then both of the objects are currently holding reference to each other. And then in counting your reference algorithm, they have the count 1. Okay, and nobody will be able to release those objects from memory. So this is the major flaw of counting references. This is why the garbage collectors these days aren't using counting references. In V8, in mark and sweep, it's much more easier to detect circular references, because some place in the code will still reference one of the objects that you have circular reference between them. So this is the problem. Having two references to each from two object, one to another object, and then not being able to release those because each object reference another object which reference itself. So
yeah, exactly. So as I understand, the garbage collector algorithm just checks first if the references are, and if there are no references, it cleans. So yeah, circular reference blocks it somehow. Although, and how about non-V8? Like, I don't know, behind Safari or
most of the browsers today uses mark and sweep and not reference counting. So there are ways in the garbage collector to detect a circular reference, and then if it detects a circular reference, it will try to figure out whether to release this memory later on or not.